Hello guys, welcome back. So in this video we are going to understand today contest problem that we have find subsequence of length k with the largest sum. Okay, and the question is saying that you are given an integer array that is called nums. Means we have given what array that having name nums, and there is another things we have given is integer k. Two things we have given, nums we have given, and integer k. As you can see in the example, we have given what nums we have given, and we have given example. So these two things we have given, nums we have given and k we have given in the example, right? And we want to find what we have to find what nums of find a subsequence of nums of length k that has the largest sum, right? So you know the subsequence, right? What is the subsequence is there, right? So subsequence, what is subsequence? Yesterday we discussed, right? So subsequence is formed by removing some element from the array without changing the order of the remaining elements, right? So we'll discuss little later. Okay, just understand, return any of such subsequence as an integer of length k. Okay, and the definition is also saying that subsequence is an array that can be derived from another array by deleting some or no element without changing the order of the remaining element. Okay, means our goal is to select a you can say or pick a element without changing the order of the length k such that sum of the selected element is maximum possible, right? And we should remove, or sorry, we should return any valid sequence of length k whose sum is largest sum. Okay, so this is the problem statement saying. So let's understand. I was talking about the subsequent. What is a subsequence? So let's understand what is subsequence. Okay, so what is subsequence? So subsequence is saying that it is an array, right? Means a subsequence can be formed, right, by derived from another array, right? It can be derived from another array, or you can say string, right? This can be possible, either a string or array, right? So in this case we can say array because the example is based on the array, right? But the sequence is formed by removing some elements from the array, right? Here, as you can see, by deleting some or no element without changing the order of the remaining element. So you should not change the order. Without changing the order of the remaining elements, you have to form the subsequence. Let's suppose in this case, let's suppose we will take an example. Let's suppose we have an array that is called nums, right? And this is what 2, 1, 3 and 4, right? So if we have an array that is this 0, 1, 2, 3, okay, so these are the index. So if I will remove an element from the array and we want to create a subsequence, right? So let's suppose very first I will remove 1 from here, right? So after, if we'll remove what 1, then if the subsequence will remaining element in the array will become what? Let's suppose 2, 3 and 4. What is the remaining elements? So these 3 are the remaining elements, correct, in the from the nums, and this is a valid subsequence. Again, understand, if we will remove let's remove 2 and 3. If we will remove 2 and 3, then what will become? The remaining 1 and 4, correct? The remaining array is 1 and 4. This time let's suppose we'll remove 3 and 4, right? 3 and 4. What is the remaining elements is here? We can say 2 and 1, right? 2 and 1. If we'll remove from here, this time let's remove from 1 we have removed, 2, 3 we have removed, 3, 4 we have removed. Let's suppose we'll remove 2 and 1 this time. So the remaining will come what? 3, 4. Okay, means we will delete in such a way if we are deleting the array whose let's suppose in the middle of the element we are removing, so in this case the remaining was what, 2, 3 and 4. So the order, so 3 will come after 2, 4 will come after 3, so this order is fine, means this is valid, and so on we can say that, correct. If we'll remove 2 and 3, right, so the remaining order is what, 1 left, so 4 will come after 1 and this is following. So this way we can create the subsequences, right. So you cannot shuffle the element. Let's suppose if you tell, so after removing 1 you will write 3 1 3 1, let's suppose removing 1 3 4 and 2, right, this is not valid, understand. So you have to understand, if we will shuffle the element, means we cannot shuffle the element, and because the order is preserved, this order will be remain, as you can see, right, order remains same. I hope you understand. Still if you have doubt, please ping in the comment box. Let's understand example 1. So let's understand example 1. So in example 1 what we have given, we have given 2 1 3 3 and k, and we need to select how many elements, 2 elements we have to select, right. We need to select 2 elements in this original order that we have given, right, and whose sum is the largest, whose sum should be largest. So if we'll take 2 element, right, right, from this array, right, so if we will select 2 element, right, so what were the possible element in this sequence, right. Let's suppose the array is what we have given, 2 1 3 3, correct. So this is the array we have given, 0 1 2 and 3, these are the indexes. If I'll take the 2 let's suppose very first 2 element, right, what will become, it will become 2 and 1, we can select. So if we'll take 2 and 1 from this array, right, so if we'll do the sum, what will be the sum, if we'll take the sum, 2 plus 1 is what, 3, we can say 3. Next we can choose 1 and 3, right, but this time what is coming, sum will come what, 4. So if we'll take 1 and 3, and so the sum is what, 4, correct. If we'll take, let's suppose this one 2 and 3, let's suppose we'll take, right, 2 and 3, the sum will come what, 5. Similarly you go with other elements, right. If you observe, there is many possibilities are there, but if we'll select 3 and 3, because 3 and 3 2 elements are what, bigger elements, so this time the sum will become what, 6, right. So the maximum is coming where, when the sum is what, 6, when the sum is 6, right, it is, this is the maximum one, right, and this means maximum is largest one, right, and so the answer is 3 3, as you can see here, the answer is 3 3, understand. So like that we can say, if we will increase, right, if we'll select these 2 elements, right, from the array, means this will be the largest one. Similarly if we'll talk about this, right, it is also happening. You can pause and you can find the sum like this, right, you will get that minus 1 3 and 4 will become what, largest one, because the k is 3, so we have to select 3 element here. Okay, you pause and try by yourself. So let's understand what is the intuition here, right, what is the intuition, right, what is intuition, just think, right, means in the very first step what we should do, right, the largest sum we need k largest number, right, if we want to find largest sum, right, we have to find what, largest sum. If we want to find in the very first step largest sum, right, so for the largest sum what is needed, it needs k largest numbers. For in this example, right, if this is an array, these 2 are small, but these 2 are bigger element in this nums, right, and so we have selected 3 3, correct, so that we can get the largest sum. Means largest sum needs k means 2 elements, or you can say largest number in the array. So if we want to find the largest sum, means to get the largest sum, it is obvious that we need to pick how many elements? K elements, right? K largest value we have to take from the array, right? And that is why we have taken these 2 elements, right? But here is the twist. What is the twist? So you can't pick what? Any key values or that order matters, right? So let's say, what I'm trying to say, if we have what nums we have in this example, let's suppose, just go through this example, okay? Let's suppose example we have 5, 1, 3, 6 and 2. If this is an array we have given and k equal to 2 we have given, okay? So top 2 element, if we'll understand what we have here given, so top 2 element is 5 and 6, correct? Means 6 and 5 are the 2 top values, right, in this array. But if you return, let's suppose 6 and 5, right, because 6 and 5 are the 2 elements, and if you return 6 and 5, right, if you return, because if you want to find the largest sum, largest numbers from the element, it means you will return first 6 and then 5. So if you take this as a what? 2 element, right, then what? This is not allowed. It is not allowed because if you return 6 and 5, that is not allowed because 6 comes what? After 5, and you have reversed the order, right? You have reversed the order. So we must find the k largest value in the preserved order as it appears in this original. So in this case, if we'll take 5 and then 6, right, so this is perfect. We can return like this, correct? We can return this, but we cannot return this. So you should not reverse the order. So if you make a sorting, right, if you're making the sorting, but the problem is if you sort this element, if you will take the 2 top element, right, it means you will do the problem like this. So you have to think like, you cannot directly think that let's sort it and you will get the top 2 element and just return it, right? No, it doesn't demands you the sum. It demands you the top 2 element with the preserve order, right? You can do the reverse, right, but it will affect you if the constant will be dead, and so the problem will become, the answer will become wrong, right? Means so we must find the k largest element from the nums, right, but we have to preserve that order as it appears in this order list, right, in the array. So there is one thing that we can do, right? What we can do, just think, let's suppose if we will tag each numbers, let's say 5, 1, 3, 6, 1, 2, right? If we'll tag each numbers with its original index. What is the original index? 0, 1, 2, 3 and 4. Okay, so we can later preserve this order. Understand? Means first of all, you do the sorting. I told you we can do the sorting, but if we tag each number with its original index, that is 0, 1, 2, 3, 4, if this order for each element is preserved, right, so you do the sorting, no problem. Now you can pick, right, in the in the very first step, right, what we should do, just tag each element in the original index, right? Then you can do what? Just pick the k largest element, the highest one. You can take the 5 and 6, right? Then you have to sort, right, sort them by index, right? So if you will sort this by without the index, this is wrong. So you have to sort it, so that if you sort these element that you have selected, the top 2 element, right, top k elements, you can say, not 2, if we pick the largest k element from the array, let's suppose we call it this, in this case 6 and 5, then what we should do, we'll sort this element again, right, in what, by index, to maintain the original order, and that makes it a valid subsequence, right? So, and then we'll extract just 2 of the 2 from the top k element and will give you the value, correct? So this way we can write the code. Understand? So just imagine what is the what type of this problem is, right? Just imagine you are hiring top 3 score, right? Let's suppose there is a HR team, right, and we have to find top 3 you can say what, top 3 scores, right? So if Leetcode want to find top 3 score from a contest, right, but they must present in roll number wise order, let's suppose. So first shortlist the top 3 elements, then arrange the order by what, roll number, and that this way the order is restricted because the subsequence condition is matching, right? So why we can't do the sorting of the whole array? Because if we'll do the sorting of the array, right, that will gives you the top k element, but their position will not be in the order, right? No position of their order will be their positions, like 0 1 2 3 4, this position we will lose. So if you lose the index, right, you have break the subsequence rule, right? And so we should follow this approach, right? And we have to preserve the index of the sorted order, and then you can get the sorted by index. Understand? So basically we can say that we want to find the k largest value, right, but you cannot shuffle them. So pick the top element, right, from the array, right, by with its index, and then sort them by the index to return the subsequence. Okay, so this is our complete intuition. Okay, so let's understand what are the approaches here. So there are multiple approaches that you can do, right? What you can do, like in the very first step, you can sort with index, right? So if you sort with the index, right, so in this approach, right, the benefit is that it's very simple, right, as we understand, and it is like slightly slower than the heap. Okay, so the second approach that we will use, because this will give you almost the time complexity O of n log n, because we do the sorting, right, and a space will take O of n to store the values, right, with the index. Okay, and if we'll take the heap, right, we can say mean heap, mean priority queue, right? If we'll take the mean priority queue that we are going to understand in this video, right, so this will take for the heap, right, n log n, right, we can say that, sorry, O n log n, and k log k, right, it will take. And if you talk about the space complexity, it will become O of k, right, because this is faster for a small k if k is small, right? So this will become faster, slightly more code, but it is less intuitive, it will come, right? So this is approach is better. Okay, let's understand what we need to do. So let's understand that we are going to use what, we will use heap, right? Heap approach means we'll take the minimum priority queue, right, queue, and this approach we will use in this example. Okay, so if we'll use this approach, let's suppose we'll take an example, right? Let's suppose the nums that we have given here is what, an array, and this array is nothing but 2 1 3 3, the first example that we had given, right? If we'll take this as example, let's call it like this. Okay, and k was given 2, correct? So if we'll take this example, it means what we need to do, we have to return the subsequence whose k is equal to 2 with the max sum we have to return with the preserving the order. Let's suppose we'll call it 3 3 in this case, right? So we'll get it, right? So if we'll return, if we want to return the subsequence of length k equal to 2 with the minimum sum, maximum sum, so we have to preserve the order also, right? So what we need to do, so in the very first step, what we need to do, we'll use the min heap to store the top largest element, top k largest element along with their index, right? So how we will do that, right? So let's suppose we'll call, so very first step what we will use min heap, right? That will do. So we'll define the priority queue. This priority queue is nothing but your min heap, right? So min heap will use to track the top k element, right, by the value. Okay, so we'll take the priority queue and we'll take a type what as an array, because it will store what we will use this priority queue min heap, that will store, you can say there should be one value, right, and another should be index, right? So each array, you can say, will store as a value here on where, on the priority queue. So if we can say, if there is a queue like this, let's suppose, so let's suppose the first person that it is sitting here, right here, so he has a value and it has its index. We'll call it, let's suppose 2 and 3. So 2 has a index. If we'll talk about 2 index, so 2, its index is 0, right? Index is 0, 1, 2 and 3. So if we'll call as a person who is in the queue, so next person will be here, let's suppose, right? So the next person having the same value, we have value will be there and there will be index will be there. Let's suppose we'll call it what, 1 0 1 and 1 1, right? We can say like that. We have to put into a queue, right? So this will become a queue, a priority queue, we can say, or you can say min queue. So this will help only the top k element, right? It will keep only the k element. We can keep the top k value element, you can say. So it will preserve the order, right, for the sort after sorting letter, right, we can say. Next understand what we should do. Next we should make a loop, and that loop will build the heap. Okay, so in the very first step we have created what, we have created the heap, minimum heap, to store the top k element, right? And now what we need to do, we have to make a loop, right? So that if we loop through the array, then we can that we have used a heap, we will add the elements. So nums at I and its index will keep adding all the element like this. It will get added as we have understood here, right? Then if the size is greater than this, then we can remove the smaller one. Okay, if size is greater than k, remove the smaller one. Okay, then you will have the priority key will contain what, will keep only the top k elements on here, right? There can be many elements that we can add by like this, but we have to remove the smallest one. If the value is increases, just remove the smaller one and keep adding. So let's suppose for the first time, these are the things we have, 3 and 2 we have given, then we have 3 and 4 we have given, right? So let's suppose the loop will start, right? So we have how many at 0 1 2 and 3. When I is at 0, we are talking about line number 8, right? When I is 0, the very first we will add it on the queue is 2 and 0, right, as a single element, right? So we'll add on the priority queue. Next we will add 1, so we can add. So if you observe that the priority queue, when we have inserted this, so priority queue size is 1. So if the size is not greater than k, so it's fine. Now we'll add the on the priority queue 1 1. When we'll add 1 1, its size is not greater than equal to, it's equal to k. When we'll add this one 3 2, right, then the sizes increases. So when the sizes increases, we'll remove the smallest one. So over here, give me 1 second, over here, like 2 0 1 1 3 2, which one is the smallest one? The value of the value will be decided, right? What is the value between 2 1 and 3? Which one is the smallest one? 3, right? So we'll remove from the 3. Understand? Then we'll add what, 3 4. When it will come 3 4 means we are calling 3 again, right? We are getting the 3 again. So we have already removed this one, so we have 2 and 3 on the list, and we have just added what, this one. So which one is the smallest one? This one. So we'll remove this one. So remaining is 3 3, and we'll return this letter. But 3 3 we have, so we'll add, we have on the priority queue. That is why I'm saying if we'll define the priority queue, right, we'll keep the top k values and will preserve the original index for sorting later, right? Now understand, we will collect the top k element with their original indices. Understand? Give me 1 second. Okay, just think that in the next step what we need to do, so this is your second step, this is your third step. In the third step, what we need to do, collect the top k element with their original indices, right? So let's call it we can say selected value, right? So we have to select, so this is also a pair of this will be in the pair, right? So these two value we have to select, right? Let's suppose, so if priority key is not empty, we can poll this element 3 to 3 4, right? And we can add into the list of these pairs, so we can add here, right? So let's suppose we have 3 2 and 3 3, right? So what we will do, we'll check if the heap contains the top k element with the original indices. So yes, we have here. Just check with while queue is not empty. Yes, not empty. Let's get one by one. So we sort by the index to preserve it, right? So who will sort it? This array will get sorted, right? How? Here, select dot selected list, right, or selected pairs dot do sort a comma b and a1 b1, a1 minus b1. It means the element will check the index, this index and this index. If it is sorted, we are fine. If not sorted, it will automatically get sorted, right? Now we just need to finally we'll need to create an array of top k element, array of size k, and make a loop, and you get the values from the selected, because we have sorted it. Just get it on the array and return it. It means you will, what we will do, you will have the list of these two, means the list, selected list will contain what, 3 2 and 3 4, right? You have done the sorted, so this is already sorted, right? So after the sorted, it will become what, 3 2 and 3 4, correct? This is your list, right? From the list, what we will do, we'll go for the loop. We'll get this element at index 0, right? Get at I at 0. So what we'll get, we'll get 3 and we'll get 3. So we'll add into the where, we'll add into the result and we'll return the result. I hope you understand. If you still have doubt, please ping me in the comment box. I'll help you there. Thank you guys. Thank you for watching this video. If you still have any doubt, please ping me in the comment box and let me know in the comment box that you like this video. So it will motivate me to create a better videos for you. And thank you for subscribing. If you're not subscribed, please subscribe the channel. And if you have any suggestions, please put the message in the group, or you can send the comment. You have our WhatsApp number. You can get the WhatsApp number from there, and you can ping us, okay? And let me know if you have any doubts. Thank you for watching this video. I've already explained the time complexity, so just ping the time complexity in the comment. Thank you for watching this video.